This little video is meant especially for old-time radio hams, amateur radio operators. Like me, I would like to describe a little trick. If you have an older receiver, such as the Drake R4, this is the receiver that I had, the Drake R4A actually, way back in the 1970s. My dad bought me a Drake R4A and T4X combination for my birthday, and I was just absolutely overjoyed. It was fabulous. I spent hours and hours and hours down there. I was on the swim team, as I remember, and between swimming and ham radio operation, I scarcely had time for anything else. And this was down in the basement in what we call the fallout shelter, which a lot of people built those after the Cuban Missile Crisis in 1962 or thereabouts. And we had this, we went down there. I lived in Minnesota, and we had tornadoes in the summer sometimes, and we'd go down there and hope the house wouldn't fall on us, but if it did, we at least wouldn't get crushed. Getting back, though, to the radio, the Drake R4A. Now, other radios are similar in design to the Drake R4A. It's a super heterodyne receiver with a design something like this. Antenna, a sensitive front end, pre-selector, tunable oscillator, a mixer, these various switchable frequencies, mixer, intermediate frequency, that's what IF stands for. Intermediate frequency amplifiers, then the detector, and finally the audio amplifier. This detector could vary. It might be an AM detector, it might be a product detector for Morse code and single sideband and radio teletype, things like that. Anyway, what I'm going to focus on here is this IF chain right here, and in particular the notch filter. Now, this old Drake R4A radio had a very, very good notch filter. The selective circuits, which are part of the IF amplifier chain, there were, I believe, 3 different selectivity settings: 2.4 kilohertz, 1.8 kilohertz, and 0.4, pardon me, yes, 0.4 kilohertz, 2400 hertz, 1800 hertz, and 400 hertz, thereabouts. These responses, though, were not the rectangular responses that you see in bandpass filters these days. They were more bell-shaped curves. They looked more like normal distributions in statistics. The skirts were not particularly steep, so that they didn't have that squared off characteristic, which is so nice to have, that rapid drop off at the frequency cutoffs. They tended to kind of gradually go down, and so it wasn't really the greatest in terms of today's standards, but back then it was really state of the art. But what was exceptional about the Drake R4A was its notch filter. It was so sharp and so deep that I almost wished I had a vernier control on the notch filter adjustment to adjust the frequency, because it was just so sharp. If an interfering character would interfering character, well, on CW, one of those too, maybe. Interfering carrier or heterodyne were to come in there, you could really notch that thing out. Well, 400 hertz is not all that great for Morse code reception, especially when you want a really sharp degree of selectivity. So I got it into my head that what I might try is to take the output of this intermediate frequency amplifier right here, the second one, and feed it right back in to the notch filter here. Now, most amplifiers invert the phase of the signals that pass through them. These were, I believe it was a vacuum tube, single vacuum tube amplifier. This radio is entirely vacuum tubes. Even the low power sensitive parts like the front end and the mixer, everything was vacuum tubes, so it would invert the phase of the signal. So what I decided to do was to try feeding back some of this intermediate frequency signal, not all because it was amplified, just enough back into the input of the notch filter so that at all frequencies except the frequency of the notch, the signals would be canceled out. But at the notch, they would not be canceled out. So what I would get then, in effect, would be a notch inverter. I forget now whether I actually did it here or whether I took the output of the notch and fed it back into the input of the first IF amplifier, something like that. I forget exactly how I did it, and I've lost the schematic diagrams that I drew for this particular scheme. There are other radios that are similar in design to the Drake R4A, old vintage radios like the Collins 75S3B, I believe it was, or 75A4. The 75S was the transmitter. 75A4 Collins radio, and there were others, even shortwave radios, anything that had a notch filter in it. You could do this. And if you did it just right, and you had to do some trial and error, if you did it just right, what you would end up with is an inverted notch. Now here are graphs of a relative frequency response for, say, let's say this is centered at 700 hertz, so we might have a 400 hertz wide, 6 dB down, 400 hertz wide, quite a lot wider at the 60 dB points, or is it 3 and 30 dB for power, 6 and 60 dB for voltage. Anyway, the response looked something like that. This was the 400 hertz filter. The notch was quite a lot sharper. It was probably even sharper than what I've drawn here. But by inverting this notch, in other words, what I could do is just invert that notch by feeding the signal back out of phase and then adjust the notch to coincide with the center of the peak. So these two filters, the original IF selective filter for CW, Morse code that is, and the inverted notch would conspire together to produce what might in effect amount to a really sharp response. Something like that. And that was my theory. That was what I thought would happen. So I fooled around with the circuit, and indeed that is exactly what happened. And I had the sharpest Drake R4A receiver this side of the international date line. That old radio, I never gave it away. I never sold it. It just sat and sat and sat after I went to college and went away. I took the radio actually to Connecticut when I went to the American Radio Relay League and worked for W1AW, and also as a assistant technical editor at the magazine there for a little while. And I lived with some guys, and we had stations in the basement out on a few acres there with a 90-foot tower and all the good stuff, you know, except the 160-meter antenna. That they just didn't have, and I couldn't bring myself to climb that rickety old 90-foot tower and risk my bones to put up a 160-meter. I wish I had now in retrospect. But anyway, I had that R4A, that old R4A, and then, I don't know, I took it to Miami when I moved there in 1979, and I had it there. And I had it for quite a while, I guess up until about the early 1980s when I got a little bit preoccupied with other aspects of life, and the result of that was that the radios just ended up being packed away somewhere. Sat there, didn't really do anything except move with me from place to place. Got jostled around, the tubes went soft, the tuning knob in there, the gears locked together, and the old Drake R4A faded away like a good soldier. But I remember that I had that with that vintage radio, and if you have a vintage radio, or if you're into vintage radios, and you have one that has a notch filter, you might want to try this mod and see if you can make it work. If you can, and if you like to receive Morse code, CW, you'll have an RF filter, a very sharp RF filter, and there's always good advantages to having the filter be in the radio frequency part of the radio, not in the audio frequency part after the detector, but in the radio frequency part. It worked great, and if you've got, like I said already 3-4 times, old man repeats himself, this was the great, one of the coolest things I ever did with that receiver. I did some other pretty exotic, cool things with it too, and if I get around to it, I'll yammer into my computer for you about those. Stan Gibilisco saying 73, signing off from the Black Hills of South Dakota, United States of America.